Okay, so for this problem, I want to find the location of this plane right here, um, the shaded area. Okay, and what I'm going to do with this one is I'm going to break it up into three pieces because the equation I'm going to use, say, for x bar is going to be the summation of x tilde a all over A. So I'm going to find discrete areas, discrete centroids, and add them together using that equation. So what I'll do here is I will have number 1 here, okay? This will be number 3 right here, okay? And the triangle will be number 2, okay? And what I want to do for each one of these, okay, 1, 2, oops, and 3, okay, is I want to find the area, I want to find x tilde, and I want to find y tilde. So remember that my origin is right here. So everything is, all those coordinates are going to be based on that. So for example, the area of that top rectangle is going to be 18 by 8, which is going to be 144. Okay. And the location of the centroid, say for the x centroid, okay, it's going to be 9. But again, that's going to be 9 from one side. From the origin, it's going to be -3, right? And then up here is going to be half of that 8, which is going to be 4. Okay, so that becomes -3 and 4 for the center of that rectangle. Again, pretty simple, but just remember you're basing it off of my x and y axes that I have got right there. So the next thing I'm going to do is go to the triangle, which is area of a triangle is 1/2 base times height. So I have 1/2 times 9 times 6, which becomes 27. Okay, now the question becomes, okay, where's the centroid of this guy? Okay, and the thing about the centroid is it's 1/3 from either side, right? So here is going to be 9 divided by 3, or 3, and then from here to here is going to be 6 divided by 3, or 2, and these will both be negative. Nope, x will be positive, y will be negative. So x will be uh, 2, and y will be -3. Okay, now going to the parabola. Okay, the area of a parabola, you can look that up in the back of the book. Have a whole table there that you can look that up, and you can see that the area of a parabola is going to be 2/3 times each of the distances, which will be 12 and 9. Okay, which gives me 72 for the area. Now, when it comes to the um, centroid of that parabola, okay, that point is right here, okay? And this distance, okay, take note where the vertex of the parabola is, okay? So from the flat side there, okay, that's going to be 3/8 times 9. All right. And then the other thing I have is from the vertex to the centroid, that distance right there is going to be 3/5 times the 12. Okay, and again, you get this from the back of the book. Okay, we have a table there that you can look these values up. You just want to make sure you orient it correctly, know where the vertex of this parabola is, and figure out your distances based on the proper orientation that is in the book, and make sure you get that right. So that x is, now keep in mind this x, this 3/5 times 12 is 7.2, but remember that's from 12 inches, from -12 inches. So it's actually -12 plus that 7.2. That's why I get an x coordinate of -4.8, because again, I need to go from the origin. That was from the parabola's vertex. Now, the 3/8 times 9, that is from the x-axis, right? So when y equals 0, so that's, I get 3.375. Okay, so basically you break this plane up into components, find the area and the centroid of each component. Now we just plug it into this equation where we take the x tilde of each times the area of each divided by the sum of all the areas, right? So it's going to be -3 times 144, okay, plus 2 times 27, minus 4.8 times 72. Okay, be careful with your positives and negatives. Okay, and get those all in there appropriately, and then the total area is just going to be 144 plus 27 plus, that is not 7.2, that is 72, excuse me, plus 72. And from that, I get a X location of the centroid to be negative 2.98, or about negative 3. Okay, and again, that's based on the origin that I've got right there. Okay, Y bar is going to look mighty similar. X tilde, I'm sorry, Y tilde times A all over A. So I do the same thing, except this time it's going to be 4 times 144 minus 3 times 27 minus 3.375 times 72, excuse me. Okay, and we divide that by the exact same area as I had above, 140 plus 144 plus 27 plus 72, and from that I get 1.04 inches. And again, that's from the origin as it's labeled there. So again, just break this up into pieces, find the area and the centroid of each piece, and then use the equation to calculate exactly where the centroid of the entire body actually is.